Hi students, how are you? Welcome to my channel KK Physics World. Today lecture we are going to learn about Nicol's prism. In Nicol's prism we learn principle, construction, working, limitations and uses. Now we see the principle of the Nicol's prism. Nicol prism is a device for producing and analyzing the plane polarized light. We know that when an ordinary light is transmitted through a calcite crystal, it splits into ordinary and extraordinary beams, which are plane polarized. This phenomena is known as double refraction or birefringence. Here we see the double refraction diagram. In 1828, Nichols eliminated the ordinary beam by utilizing the phenomena of total internal refraction at thin film of Canada balsam, separating two pieces of calcite. Here we see the William Nichols diagram. The device is known as Nicol's prism. Now we see the construction of the Nicol's prism. Let we take a calcite crystal whose length is 3 times as its width. The principal section angles becomes 68 degrees and 112 degrees instead of 71 degrees and 109 degrees. This done to increase field of view. The crystal cut into two pieces by a plane perpendicular to principal section. Here we see the Nicol's prism. The two cut surfaces are polished optically plane and joined together by a Canada balsam. Here we see the Canada balsam in the diagram. Refractive index of ordinary ray NO equal to 1.658. Refractive index of Canada balsam N equal to 1.55. Refractive index of the extraordinary ray N equal to 1.486. From the above values, the refractive index of the Canada balsam lies between refractive index of the ordinary and extraordinary rays. Now we see the working of the Nicol's prism. Here is Nicol's prism diagram. When a beam of light AB enters the face PR, in diagram we see the light beam AB, then it splits into ordinary plane polarized light and extraordinary plane polarized light beam. Here we see the ordinary plane polarized light BO and extraordinary plane polarized light BE. Previously we discussed refractive index of the ordinary ray and the refractive index of the Canada balsam. Refractive index of the extraordinary ray. It is clear that Canada balsam acts as rarer medium for an ordinary ray and denser medium for extraordinary ray. The incident angle of ordinary ray at calcite balsam surface is greater than the corresponding critical angle 69 degrees. Note: the refractive index of the ordinary ray with respect to the Canada balsam N equal to 1.658 by 1.550. Therefore, sin C equal to 1 by N equal to 1.550 by 1.658 or C equal to 69 degrees, where C is critical angle. Under these conditions, the ordinary ray is completely reflected at calcite balsam surface. The extraordinary ray is not reflected because it is traveling from rarer medium to denser medium. Thus, it transmitted without source of intensity. Thus, only extraordinary ray is transmitted. Since extraordinary ray is plane polarized, having vibrations parallel to the principal plane, the light emerged from the Nicol's prism is plane polarized. Now we see the animation of the Nicol's prism. Here we have ABCD, that is Canada balsam crystal, which is placed in between calcite crystal. When we put an ordinary light into Nicol's prism, then it splits into two rays. In that, one is ordinary ray and another one is extraordinary ray. Ordinary ray is reflected from the Nicol's prism and extraordinary ray is transmitted through the Nicol's prism. In extraordinary ray we have plane polarized light, which is have no loss of intensity. In ordinary ray we have change in intensity. Now we see the limitations of the Nicol's prism. The Nicol's prism acts as effective polarizing device with a slight convergent or divergent beam of light. Here we see the Nicol's prism diagram. The incident angle is less than the angle of RBA with phase pair. Here we see the incident angle RBA. Then the ordinary ray angle of incident at Canada balsam is less than the critical angle 69 degrees. Here we see the Canada balsam incident angle. Thus, the ordinary ray is not reflected but transmitted through the prism. So both ordinary and extraordinary rays are transmitted through the prism. The incident angle is greater than the RBA with phase pair. Thus, the extraordinary ray also suffers total internal reflection. Here we see the angle RBA. Now, no light will emerge out of the prism. Hence, to obtain plane polarized light, the incident beam should be confined within the angle of 14 degrees on either side of AB. Here we see the 14 degrees on either side of AB. Now we see the uses of the Nicol's prism. Nicol's prism can be used as both polarizer and an analyzer. When two Nicols are arranged coaxially, then the first Nicols, which produce plane polarized light, is known as polarizer, while the second, which analyzes the polarized light, is known as analyzer. Here we see the diagram of the polarizer and analyzer. When their principal sections are parallel to each other as shown in figure A, the extraordinary ray freely transmitted by both Nicols. Here we see the figure A. In figure A we have maximum intensity of the light. In figure B we have no light. If second prism is rotated gradually, then the intensity of the extraordinary ray is decreased. When the two Nicols are right angles to each other, then there is no light from the second prism. In figure B we have no light from the two Nicols. Here is intensity of light. I hope that you understand the class. Thanks for watching my videos. Please subscribe my channel. Don't forget like, comment and share. Thank you.